Good morning, good afternoon, good evening, whatever it is, wherever you are today. I'm Ali Amagasu, and you're listening to the latest episode of Cloud Unfiltered. Today, I am happy to welcome back one of our most popular guests and our only three-time guest, Ed Warnicke. He is a distinguished consulting engineer at Cisco. Welcome, Ed.
Good to be here.
So glad to have you back. We love how you explain things. Thank you. With Ed today, we're going to talk with Frederick Kautz. He's a principal software engineer in the office of the CTO at Red Hat. Welcome, Frederick.
Thank you.
Glad to have you on the show. Pete, you're really a host of the show, but welcome, Pete.
Thanks, Ali. I think if you're into playing the Cloud Unfiltered drinking game, you're going to be disappointed today because I think we're going to go pretty deep on networking instead. But this is going to be a good conversation.
Yes, I'm really looking forward to it. So everybody, before we get into the technical bits and pieces, what I'll say is it's going to be great if you're interested in Kubernetes and in cloud networking. If you're interested in both, you've really hit the jackpot today, because that's what we're going to talk about. We're going to talk about network service mesh, which I don't know a lot about what it does. I'm going to find out today, but it has to do with what Kubernetes does for networking. And so, gentlemen, with that, who would like to introduce the topic, Frederick or Ed? Can you explain kind of what this is and why we need it and why it's exciting?
Mind if I take this real quick, Frederick?
Go for it.
Awesome. So if Kubernetes right now has a perfectly lovely networking API and networking system for the purposes for which it was built, they've actually done a kick-ass job of allowing people at layer 4 and above to get their work done. So I'm making HTTP calls, for example. I'm accepting HTTP requests. Those things are done brilliantly. And then with the entree of Istio, they get even better as you start bringing service mesh for the layer 4 through layer 7 crowd. Network service mesh touches absolutely none of that, right? That works beautifully. But one of the things that's starting to emerge is if you have problems that do not live up there, that are at lower layers like IP or Ethernet, than what you're dealing with in Kubernetes, that the Kubernetes API doesn't really do you any favors, right? So in the Kubernetes networking API, the following concepts both don't exist and are actively not wanted. Interface, subnet, route, nothing. None of those things exist in the Kubernetes API, and they don't want them, and they shouldn't, because they don't serve their core constituency. So network service mesh essentially looked around and said, okay, we have to solve these problems. We have to solve them for the NFV guys and service provider who want to use Kubernetes. We even have to solve them for a bunch of enterprise use cases where people, for example, may want a pod in Kubernetes to be able to have secure connectivity back to their intranet. And there's just a myriad of places where you have to solve these problems. Let's go look at the really cool stuff that's happening in service mesh with Istio and see how much of that we can bring back by analogy to payloads that are layer 2 or layer 3 payloads instead of the normal layer 4 and above that they deal with. And that was sort of the impetus for network service mesh. So at a very high level, if you think of it as being like service mesh, but with payloads that are Ethernet frames and IP packets, that's a really good place to start.
Excellent. I think that helps it make sense for me. Pete, I can see you want to ask a question.
Yeah. So Ed, let me try to unwrap that a little bit from an app dev perspective, right? So kind of, if you go back 25 years, right, it was you got IP address and port number. If you're operating at layer 7 and you're an app dev and I'm trying to connect two components, whether that's a web server and a database server or what have you. And back then, we didn't have, like in the early 90s, we didn't have standard protocols for doing that, right? So it was, I have all kinds of funky port numbers I might use, and I might collide with somebody else. And then ultimately, sort of after HTTP was published, we kind of standardized on port 80 and 443, and we standardized on HTTP. And for RESTful-based APIs, we started to stuff all kinds of cool things in the headers and the request and response bodies so that we could components could communicate over these protocols and over these ports, and our network friends were way happier because now they had far fewer ports to have to try to administer, right? So then we get into Kubernetes, and we have this opportunity to change the way that we kind of name things, right? I mean, if you didn't want to operate at an IP address or port number level, you had our friend was DNS, right? So I didn't have to remember what the individual IP address numbers I might have, prod-database1 at .cisco.com, and what that pointed to might change based on what's going on with deployments and so forth and so on. Mm-hmm. So then Kubernetes comes, right? And we have this opportunity to now redefine what we even mean by namespaces and how the networking works. And as you talked about, so Kubernetes has this really nice CNI interface that you have all these plugins that you can use, whether that's standard Calico or whether that's Contiv, which Cisco contributes to, or whether you want it to integrate with something like your existing ACI environment. There's an ACI plugin for that. And then kind of layered on top of that is what's kind of in its infancy, I would say, is the Istio, which is kind of broadly speaking, kind of the DNS equivalent for this Kubernetes world, so that I have a way of, if component A needs to talk to component B, how does it discover it's there? And Istio is the answer. But it sounds like what you and Frederick are talking about here is, okay, that works great for layer 7, but what if I want a VPN between a Kubernetes cluster and something else I have on-prem? Or what if I want to VPN connect two Kubernetes clusters, one of which might be on-prem and one of which might be running in a public cloud? How close am I to, I mean, I did spend there's a lot of exposition there to sort of set the stage, but how close to that, how close is that to the problem space that you guys are looking at here?
So yeah, so I think that you're hitting it quite well. I mean, like, network service mesh itself is a bit more broad in its capabilities, but those squarely fall well within some of the things that we're looking at. So, for example, we have a narrative about Sarah, how she has not just a cluster, but specifically a pod that she wants to have secure internet connectivity to, and okay. So the entire set of things in terms of how you set this up, if you're to try to do this in a Kubernetes cluster today, you'd have to go find information about the routes, what CEDAR ranges to add in. You have to create the subnet. You have to work out what IP address you want that subnet to be. How do you inject those routes into your pod? How do you set up the interface? How do you IP that pod, and so on? And there's a whole range of operational things that have to be done in order to land that pod into the VPN. And so step one is, well, how do we simplify that entire chain? And so we started focusing on that as a specific problem to help guide us towards what we want network service mesh to look like, but also keeping in mind that there's other problems that we want to try to solve, or other use cases that we want to solve. And so how do we keep it generic enough so we can solve other use cases as well? Okay.
Well, so the holy grail to me that we haven't quite reached yet, right, is this idea, at least from an app dev perspective, that I have a certain number of microservices and I don't necessarily know or care where they run, yep. Right? And some management component might burst those between, say, an on-prem cluster to a public cloud cluster as needed, keeping in mind that certain pods are going to have latency affinity for one another, right? And are the ones that are noisier, you're going to want to group together, and so forth and so on. And Istio helps with some of this discovery of that, but it also makes kind of a fundamental assumption that everybody is cool with just going across the public internet over HTTPS with port 443. And it sounds like you guys potentially have some plumbing here to make that more secure, to make that holy grail more possible.
Yeah, I mean, it really depends on what you want. I mean, so I take what you said actually a step further. It's not even that you don't know some of these things about where your things run. It's that you actively don't want to.
Yeah.
Right. I mean, I will often point out that cloud is just another word for I don't want to have to care. And that's the evolution that you're actually seeing with things like Istio, where effectively the details of how it happens are nothing you talk about. What you basically do is express the intentions for how you'd like things to happen, and then sort it out. I mean, it's sort of the tell me what you want, what you really, really want. And then it's supposed to go make it so. And network service mesh is trying to bring that into the space of things that are below layer 4 or layer 7. So for example, if you take the VPN gateway example you brought up, the honest truth is actually very few developers actually want to connect to a VPN gateway. What they want, the thing they want, is secure internet connectivity. And preferably they don't have to have any notion what that secure means, right?
Yeah.
So clearly some piece of that for certain kinds of deployments is going to be a VPN gateway because your corporate internet has a firewall in front of it that you can't get past, right? But it may also be that people have decided that there should be a firewall in front of that VPN gateway running in the cluster so you catch things early, or an IDS so you can catch and isolate these things. And Network Service Mesh will actually let you express this chaining from an intent point of view, where the person running the pod, the app developer, says, I want secure internet connectivity, because that's what they want. And someone configuring the moral equivalent of Istio, route rules, or virtual host says, when someone asks for secure internet connectivity, make sure they go to the IDS first, and then from the IDS to this, and blah, blah, blah. So that way you can actually keep the developer in a position where they only have to they only have to think and spend cycles on the part they care about, which is what they want.
Ed, you're the first person to use Spice Girls lyrics on the show. You just need to know that.
I was about to say,
it needs to be said.
I'm not sure if you realize that you did there, but now if someone Google's VPN gateway Spice Girls, this audio clip is now going to come up for all eternity. So congratulations, my friend. That was impressive. Well, let me ask this. So when would I ever say I want an insecure gateway? So I mean, you're talking about you want to give the intent to the app dev and hide the details, but some of those intents are even like default and unspoken, right?
Sure. But I mean, the fundamental thing is a lot of what we're used to in networking is thinking about the world in terms of interfaces, subnet, networks, routes, none of which actually an app developer ever wants to know exist.
Correct.
When an app developer wants something, what they really want is what we've been calling a network service. And a network service is just a collection of behaviors that get applied to layer 2 and layer 3 payloads. So connectivity, right? In the case of secure internet connectivity, I want connectivity to my internet. Security, I want some kind of security feature for that. However that ends up manifesting, I don't care. Another one that people sometimes want is quality of service. There are a bunch of these sort of collections of things, and you often get them in groups. It's part of why I laugh when people are like, well, and then we'll configure this interface to plug into this subnet. It's like, no one cares, right? They want to be able to connect to certain things. They want to get certain kinds of security. They want to be able to get certain kinds of quality of service. They may want to hit other kinds of services at higher layers along their path. That's the things that people care about. Nobody actually cares about interfaces and subnets anymore.
I see exactly where you're going. So then I also see why the Kubernetes constructs make this a natural fit, because the Kubernetes constructs are kind of challenging this old notion of this is what an IP address and a port number means, and this is what some of the fundamental assumptions of what are underneath that. And it abstracts things to a big enough it abstracts things enough that now you have a chance at thinking about the world differently. In your case, at the network layer, at layers 4 or below, where in a traditional networking, monolithic application kind of setup, you have no chance at that.
Well, to be specific, when you talk about abstract as well, it's also about abstract. What level of abstractness do you want for different roles in this? So if you're a client of this, you probably don't. You may or may not care about how you connect in. If you're a data plane, then you very much care about some of those details, and so you have to be given enough context and enough information. And so an important part of what we try to deal with in network service mesh is allow to have an abstract way to request something. So I want secure internet connectivity. Then what does that really mean? So what does it mean for your data plane if you're using, for example, VPP? Like, how do you configure that in order to connect you to the VPN gateway? What does it mean if you have to go through a firewall? And how does that firewall get its connectivity as well? So these are all like very important details. They're still there. They still have to be dealt with, but by providing context to the components that are most likely able to make those best decisions. So, for example, the VPN gateway is probably the best place in order to work out what is the CEDAR ranges I need to grab from corporate in order to inject into the pod. And so being able to grab that context, pass it back through the chain in order to set things up. So the details are still there, but it abstracts them away from the entities that don't really care what those other details are as well.
I see. Okay, so I think we have this really well defined as to sort of what this is. But let me ask the question. So how did you guys come up with this in the first place? Like, how did you come to work together on this? What's the story behind that?
I mean, we can both give our perspectives on this. So I was at Open Network Summit, and I had signed up to give a talk at 11 o'clock in the morning, Monday morning, on cloud native networking. And it was mostly going to be a crowd of folks who are service providers and interested in network function virtualization.
Okay.
And this is an area I've been sort of struggling with and trying to figure out what to do with, because the problems here looked really complicated. And so about 9 o'clock in the morning, I had nothing. And then
wait a minute, let's pause there for a second. At 9 o'clock, you had nothing for your 11 o'clock talk.
This is not as uncommon as it sounds. And so at 9 o'clock, this idea hit me, and the whole pieces started falling into place. And I scribbled down some slides and went and got up on stage at 11 o'clock and gave my talk, and it was extremely well received. And so that was awesome. And then I got a bunch of people who wanted to get together Tuesday morning in one of the sort of breakout rooms and talk about beating use cases against this. And so that sounded like a good idea. So we did that. And then on Wednesday, I walk into Frederick's talk, and I think this is where I walk into Frederick's talk, and he is talking about network service mesh on stage, which is probably a good indicator that maybe there was something here. When your ideas start showing up at other people's talks 48 hours later, maybe there's something going on.
There's some kismet there, right?
Yeah. So, I mean, part of what I have to do is I have to work out what is the cloud landscape and that kind of stuff. And talk was actually on cloud landscape, and so I thought it was appropriate to do so. And so, it sounded like a good idea.
So this makes me wonder, and some of the things you said, are you guys solving a problem that people have been encountering, or is it something you're anticipating? So what was the driver for fixing these things or creating a tool that does what this does?
So it kind of depends on whose problem. The network function virtualization people have been well aware that they have this problem for a long time. It's been a major pain point. They very much would like to be able to run workloads in Kubernetes to do NFV data plane work. And one of the big things that makes that hard is if you look at Kubernetes, like I said, it has no interface concept, no subnet concept, none of this. And if you look at a VNF or a CNF, a cloud native network function, what you see is this box. And on the top, there's a management interface. Coming in from one side, you have it that goes in, and going out the other side is that goes out. Right? So minimally, you've got 3 interfaces, and there's literally no good way to string that all together in a sane way in Kubernetes. So that was a very urgent problem when the idea came together. And since then, what we've realized is the enterprise people actually have a ton of problems that look very similar, like the secure internet connectivity problem that I described. And so it's actually one of those happy places where it looks like we're going to be able to kill multiple birds with a single stone.
Nice. So answering that question makes me wonder, is this something that exists, or is it an idea that we're excited about and working on right now?
We're typing as fast as we can.
Yeah, the answer is both.
Is both.
We have
okay.
We have a lot done. It's not ready for prime time yet. So we're very close.
Yeah.
All right.
We should have a bunch of things that we'll be demoing at KubeCon. And there are several KubeCon talks that are on network service mesh as a topic. There's a network service mesh talk at the FIDO Mini Summit at KubeCon as a co-located event. So there's been a ton of interest.
That's great. That's really great to hear. So the people who are going to be most interested in this, you're thinking off the bat, are folks involved with NFV.
They have an urgent, we can't do anything kind of problem that they need to solve. I think on the enterprise side, it's a bunch of people dealing with problems where, as in the VPN gateway problem, okay, I have this problem. I can kind of sort of hack around it in a bunch of ways that are kind of inconvenient, but at least I can function.
Right.
For the NFV folks, I think it's a very primitive problem. The enterprise folks, I think it's an enormously better mousetrap.
Got it.
Yeah, there's also, on the enterprise side, there's also another angle to it as well, where they may have certain applications where the Kubernetes networking, with the way that's currently set up, may not have enough performance or so on that you may want to have. Like if you're dealing with real-time video as an example, then being able to drop in devices that can communicate faster and wire them up properly and making sure that they do the right thing also becomes very important for those use cases. And so there's one of the things I found, though, is that as you start to look at like telco use cases or service provider use cases, and then you start looking at enterprises as they grow, they actually start to look very similar to each other, and they're different forms of the same problem. And so we feel that as this continues to grow, that and as Kubernetes continues to gain traction, that we'll see more large enterprise use cases really start to have the same types of problems that you see in service providers, which include things like, how do I make sure that I get a firewall in the right places before they hit their corporate intranet, or how do I make sure that data that's coming in this less secure area goes through the correct channels in order to, before they enter into some more secure intranet. And so like we're able to wire these type of stories up and really be an enabler for them.
Cool. So are you guys, so kind of double click a little bit on like current state. So is this, you guys both have open source background, right? So I assume that there's some kind of open source project that's a result of this. You obviously have some KubeCon talks you're going to give. Like, are you guys talking with the CNCF guys about making this? Like, where does some of that kind of governance and if people wanted to get involved kind of state stuff currently rest?
So you go to networkservicemesh.io. That's our website.
Okay.
Point you directly to the code on GitHub. There's a lot of activity going on. We have meetings every week on Tuesdays at 8 a.m. Pacific. We get pretty broad attendance from a bunch of different folks from a bunch of different organizations there. And the CNCF folks could not have been possibly, any more supportive than they are. They've just been incredible in terms of trying to do their best to help us. We're in sort of an interesting place from a governance point of view, in that we're trying to figure out among the options on the table which option makes the most sense, because we have at least 4, right? We could become a Kubernetes subproject. We could become a Kubernetes working group. We could become a CNCF working group, or we could become a CNCF project. And I think we sort of, as a community, the community has talked about all these options a great deal. And I think sort of where we've wound up as a de facto place is that we are going to continue typing, and we will deal with that later.
Yeah, there's nothing wrong with just being, being 11 people with a dream, right? And and continuing along that road until you're forced into some box later. There's certainly nothing wrong with that.
Well, and the lovely thing with the CNCF guys and the Kubernetes communities, those communities are so intensely functional that it's not even really a box. It's sort of like a comfortable nest, if you will.
Sure. Well, and I mean, what comes with that is validation, but and I'm not trying to pick on CNCF, this happens with anything. I mean, when you've got a small, group of rebels joining a larger group of established folks, there's always bureaucracy. And I know, Frederick, I'm not going to ask you because you asked me not to, but you're about to learn about that in a very real way as well. And that's all I'm going to say.
Oh, Pete, you crack me up.
Well, I had to. I mean, I've been on both sides of that coin. I've been the bureaucrat being a pain to someone else, and I've been the doe-eyed enthusiast who realizes that in order to make something bigger, you kind of have to compromise on some things, right? I mean, so why do that now when you've got when you've got all this energy and you've got people who are passionate about this? There's nothing wrong with delaying that and running on passion as long as you can.
Mm-hmm.
Yeah, and that's definitely one of the great things about being an open source project as well. Is that when you're working with the open source project, like you're looking at the community. Like Red Hat has always taken like a community first approach when it comes to these type of projects, and so like my belief is as helping drive network service mesh is that we have to get a really good solid community. We have to find ways to enable people to build and work with us, and it's at the end of the day, it's about alignment. Like if we can find the right alignment so that everyone who gets involved succeeds, and then the project as a whole succeeds. And one of the terms I like to use is like a rising tide lifts all ships. And so like that's been that's been my opinion when I'm driving this project since we first started, and it continues to remain my opinion in terms of how we should continue to drive network service mesh.
So to grow your community, let's talk about that for a minute. So what kind of skill set are you looking for, and what kind of things do you guys need help with as you're building this out?
Great question.
Like anything. I mean, if you want to be high impact right now, obviously we need more people to type code. In the long run, there's actually going to be a lot of opportunities though in different areas. So if you happen to have access to, or you are a owner of a component, we need integration for those components and hardware devices. So there's could be data planes. They could be and we spoke about VPN. So like, how do you integrate with a VPN? So there's different easy places that people can start looking at and potentially jump in that would really help in the long run. We're also looking at from an operator perspective, it's like, well, is this thing doing the right thing? Is it solving your needs? I mean, it really depends on where the person's coming from in order to work out where the right place to fit them in is. But yeah, there's a lot of places where people can help. So that's
cool. So it sounds like a variety of different things you guys have opportunities for.
There's a lot of Go code to be written. There's a lot of people kicking the tires that has to happen. There's a lot of people beating use cases against the model to make sure it can work. That still goes on and on and on, and sometimes results in people saying, "Why is this hard?" And the response is, "That's a great question." And so the model continues to get in some ways actually simpler and cleaner as a result of interactions. Documentation is always hugely welcome. There's just a ton of things to do to contribute in a truly vibrant community. And we've got people doing a lot of those roles right now, and we'd love to have more.
Excellent. Pete, looked like you were going to ask another question.
No, he said Go, so I don't know where if we want to stay at talking about network or if we want to talk about like experience with Go and why you guys chose that language, and we can get into some of that stuff. I mean, I could take us on that tangent for the next 20 minutes if you want to, so I hesitate to do so.
I can probably give you about 5 minutes to talk about that tangent.
Well, I guess let me. So, and that's what I meant about skill set. Like if I'm a Golang, it sounds like if you're someone that has experience with a specific firewall or a specific VPN technology, that there's kind of some mapping work that you guys have. But in terms of, okay, what am I typing in? Is there like it sounds like at least some of it is in Golang. So what's the skill set there? And that may or may not illuminate why you guys chose that language.
Okay, so let me start with this one. So if you are building an integration to network service mesh, like suppose you are a VPN provider and your product's written primarily with C or Java or so on, the protocols that we've created to speak with the network service mesh in Kubernetes are well defined with protocol buffers. They're well defined with we use gRPC to perform the RPC, and so you don't have to write in Go if you don't want to, and you're one of these vendors. You write with something that's compatible with that, and then you basically use whatever is best for your community in that area.
Okay, awesome. So low learning curve there.
Right. If you're operating in the Kubernetes community, there's a good chance that you're already a Go programmer, and so it makes it very easy from that scenario. If there's someone who wants to get involved, who suppose that they're a Java developer and they want to learn Go, or they're a C developer and they want to learn Go, the cognitive dissonance of learning Go is not as high as learning other languages, and so Go makes it very, very easy. The constructs, like there's a couple gotchas you have to be a little bit careful with, but for the most part, it's a very clean and very easy language. And so I found historically that people coming in from other projects that I've been involved with, that it's been very, very easy to see people get ramped up very quickly.
Well, and that's what I was hoping to pull out of you, that it's actually the little bit of Go programming I've done, and I mean, I wrote my first line of code in 1981 as an 11-year-old in Microsoft Basic, right? So if programming languages were spoken languages, I can order food in like 12 different languages, but I'm not fluent in any of them anymore, right? Mm-hmm. But yeah, Go is actually pretty low learning curve, I think, in comparisons, because you don't have like the funky async things that you have in Node. You don't have, I mean, it's compiled, so you have to go through the compile cycle, but then you get much better performance afterwards. the thing about being kind of the latest and greatest is you're borrowing the best constructs from what was out there before and kind of avoiding the pitfalls that people ran into before. And it's so similar to Java that if you know that at all, it's the learning curve isn't too bad.
Yeah, and I also found like I wrote my first line of Go in early 2013. And
oh wow!
I was a early contributor to Docker. So before Docker was publicly released, it was written in Python, and before that, it was written as shell scripts. And that's actually when I got involved. And so when we moved it over to Go, I was a little bit apprehensive at first because like another new language, and I didn't really see the point of Go. But then once I started working in it, like it was very easy to get involved, and it was obviously the right choice in that scenario. So any community that decides, we want to jump in and they're doing something that's new. Like if they're doing something already and a community is already established, like I use Open Daylight as an example. When someone says, "Oh, well, what about writing Go language, using Go in Open Daylight?" It's like, well, you have a very strong Java culture, and so you need to think really hard as to whether Go is the right approach for this, depending on who you want to attract. So if you want to attract like cloud developers who are working in Kubernetes space, then yeah, consider using Go. But if you want to work within that well-defined community, then you're better off using things that they understand. Same thing like with OpenStack, with Python, and so on. And so it really depends on the community. And in this scenario, like it's already my opinion is it's a wonderful language to work in, and so it was a natural choice for me. And then the fact that we're targeting Kubernetes as a major use case, it didn't even the choice was easy.
Sweet. Okay, that makes total sense. Thanks for taking us through.
Go is an excessively pleasant language to work in. It's just really, really nice. If you're a language polyglot at all, it's very quick to pick up. And it also has really nice side effects in the cloud space. So I think our containers are running about 16 megabytes in size because they're basically just the Go executable. So it ends up being, super small and super light and super fast to build.
Okay, Ali, I'm done. I promise.
No, that's okay. I actually enjoyed learning about it. I haven't heard much discussion about Go before. So that's great. I appreciate you guys taking a little dive into it. It sounds like the Chihuahua alarm is going off at your place,
yes, I think that
indicating that perhaps our discussion is over for the day. Gentlemen, are there any questions we didn't ask? Anything you want to get across about this project that we failed to touch on before we wrap up?
So I would say just that it is still, it is a project solving a whole bunch of really interesting problems. It's a very hot project right now, and we have participation from lots of directions, but it's still very ground floor. So if you're looking for something to get involved with that is crucially important to the future of cloud native, and that is still early enough that you can have a very high impact, Network Service Mesh is an excellent candidate for that.
Perfect. That is the perfect way to close up. Anything from you, Frederick?
I think Ed said exactly what I was going to say. So I'm come join us.
Well, thank you guys for being on. That is exactly what I heard when someone referred you to me. Was this is a hot project? You need to talk to these guys. So I dialed you up without really even knowing what I was getting into. So I'm excited that you spent the time with me. Ed, you're always a terrific guest. Frederick, it's been a pleasure speaking with you. And Pete, thanks for asking all the hard questions.
Absolutely. Yeah, Ed, I got Spice Girl stuck in my head the rest of the day, so thank you for
that.
All right, guys, thank you so much. I hope to have you on again soon.
Cool. Thank you.
Thank you very much.
All right, bye-bye.
Goodbye.